Good evening, sir.
Good evening, sir.
Okay, good evening, everyone. So, today you're which class? Chemistry or physics?
Physics, sir.
Sir, physics.
Okay. So, I think in physics we are continuing with electricity. Today, let's continue with electricity. So, see what all things we had done up to now in electricity chapter. Yeah, good evening, everyone. Good evening, Huria.
Good evening, sir.
Without wasting any time, let's continue now. So, we have to start with electric currents and see what all things we have done now, and we will be bringing up the things together to try to understand the foundation of this chapter. Okay. Whatever things we have studied up to now in electric currents, in the beginning we have studied about the charges. Okay, so can anyone tell me what were the charges? I don't know. पता कब उठूंगा? Okay, so the charges, we had seen that the charges are the fundamental quantities and they can be of two types. Either they can be positive or they can be negative. So similar charges, they attract, they repel each other, and opposite charges attract each other. This is what we have seen. Charges, you can also call charge to be a property of matter. Okay, so charge is a property of matter and it is an intensive, it is a property like which cannot be separated out from the matter. So you can assume that the matter has charges and the matter has two types of charges. Is it visible to everyone? Am I audible to you all?
Yes, sir.
It's a okay. So see, charges, it is a property of matter and we observe that there are two types of charges in nature. So if the nature does not differentiate between the two charges. The charges, they are called as positive charges and negative charges. The names we have provided them. So basically, the protons were called as the positive charges and the electrons were called to have the negative charges. We had also discussed about the relative masses. The electrons, if I discuss the mass of the electron is about 9.1 times 10 to the power minus 31 kilogram. And mass of a proton is about 1.6 times 10 to the power minus 27 kilogram. Okay. So mass of electron and mass of protons, if you observe them, the protons are about 1,000 times heavier than electrons. Okay. 1,000 times means you can, if you want to assume it as a scale, so we can consider an electron to be 1 gram. If you consider the electron to be 1 gram, then the proton is 1 kilogram. So you can very well compare how the masses are related with electrons and protons. Okay, so the electrons, they are very light, of the order 10 to the power minus 31 kilogram, and protons, they are heavy with the order of 10 to the power minus 27 kilogram. Okay, so understood these concepts. However, the electrons are supposed to have negative charges. Okay, we represent, or to count the total number of charges. Okay, so when we count the total charges, so total charge Q is given as Q equals to NE, where N represents the number of electrons and E represents charge on one electron. So what is E? E is charge on one electron. Now, can anyone remind me what was the charge on one electron equal to? Is there anyone who remembers the amount of charge on one electron?
Sir, one uh,
Is it 1.6 into 10 to the power minus 18? No, minus 19. Yeah.
Minus 19. So every electron will carry a charge of 1.6 multiplied 10 to the power minus 19 coulomb. And this charge is not breakable. That means a charge of less than this is not possible. You can't have a charge smaller than this. This is the smallest charge which is possible. Now, at any place, if you have any charge, so that charge will be a natural number multiple of this. Okay, so the total charge Q at any place, the total charge Q at any place is given by Q equals to NE, where E is the charge on each electron and N is the number of electrons. We can think of the same in terms of protons also. So just like the electrons, in the same way we can think of the protons. A proton also has the same amount of charge. A proton, if you write 1p plus or proton, it has a charge of 1.6 multiplied 10 to the power minus 19 coulomb. The charges are exactly the same. Okay, they just differ by a positive or a negative. Okay. So charge on a proton is 1.6 multiplied 10 to the power minus 19, and a charge on an electron is also the same. What is the charge on a neutron?
0.
0, right? So charge on a neutron, when we discuss of the neutron, a neutron has a 0 charge. When we say neutron, so neutron does not consider any charge, it has 0 charge.
Sir, what about the mass?
Yeah, the mass of the neutron is almost similar to that of proton. Almost equal. So yeah, the mass is almost equal. Got it? Understood, everyone?
Yes, sir.
Okay. So this is about a proton, the proton, electron, and neutron. Now let us see. We have also studied about the quantization. We have now we will be considering the movement of charges, and for that we need to understand a concept called free electrons. Okay. So what do we mean by free electrons? Okay. Can anyone tell me what do we mean by free electrons?
Sir, that the electrons can be out of the discrete orbits that they are in.
No, they are not out of their orbits. When we say free electrons means electrons which are not involved in bonding. So electrons that are not bonded, or you can say that they are free from nuclear attraction. You can say, okay, just consider that electrons that they are not bonded. We'll be calling them as the free electrons. So all the metals, they contain free electrons. All metals, almost all metals. For example, if we consider sodium, so sodium, it has a free electron. It can easily release one electron. It has one free electron. Magnesium, it also has electrons, free electrons. So all the being all the metals, they being, we can say, electropositive in nature. So metals, they have free electrons. Whereas if you have non-metals, no free electrons are available. Why no free electrons are available? Let us see. Suppose I talk of chlorine. So chlorine exists as Cl2 with two chlorine atoms bonded to each other. When the two chlorine atoms are bonded to each other, they are contributing one electron from each. Okay. So the electrons of each chlorine, they are involved in bonding. They are not free. But for the metals, we have free electrons. Right? So whenever you will have free electrons, or if you have free ions, then there will be conduction of electricity. So inside a wire, if you consider a wire, so in the wire, when we are talking of conductors, so if it has free electrons, then only it can conduct electricity. If the wire has free electrons, then it can conduct electricity. So there are some free electrons. Okay, let's see what happens. So this wire has some free electrons, and let us say I connect the positive terminal of the battery to this surface and negative terminal of the battery to this surface. Okay. So do you think that there will be a force experienced by the electrons? Yes.
Sir.
The electrons being negatively charged, they will be forced by the negative terminal of the battery, and they will start moving towards the positive terminal like this. So hence, there will be movement of free electrons from the negative terminal towards the positive terminal. This is the direction of motion of electrons. But conventional way, we will be discussing this in terms of positive charges. And I think I had discussed this a lot in detail in your previous classes, that why we consider the direction of current from positive to negative. The current will be taken from positive to negative. However, the electrons are moving from negative to positive. Got it? Here we observe that the electrons are moving from the negative terminal towards the positive terminal. But still, we consider the movement of the charge. We consider the current from positive terminal towards the negative terminal. The reason being, we have defined everything in terms of the positive charges. We have defined everything in terms of positive charges, like electric potential, the forces, and everything in terms of positive charges. So that is why we consider the current from positive terminal towards the negative terminal as a relative motion. However, even if the protons are not moving here, the protons are stationary, it is only the electrons which are moving. Understood, everyone?
Sir, is this why like metals usually have a positive charge?
What happened?
Like, is this why metals usually have a positive charge?
Yeah, this is the reason why metals easily acquire a positive charge. That is because of their low ionization energy. They are having a low bound electron. One of the outermost electron is loosely bound. Okay. Since it is loosely bound to the nucleus, it can easily move away.
Okay, sir.
And okay, another model explains it like this, that there is a sea of electrons. okay, in which the protons are drawn. So it's not just like each atom. You have a sea of electrons. Got it? Everyone understood about the free electrons?
Sir, but graphite has free electrons, right, sir, because it conducts
Which one?
graphite.
Yeah, graphite has a free electron. It has a loosely bound one electron or a one free electron. That is why it can conduct electricity, whereas diamond does not have. For diamond, all the electrons are used in bonding. But for graphite, only a few electrons, 3 electrons are used in bonding. 1 electron of each carbon is free. So it can conduct electricity. Got it?
Yeah.
Okay. So all the substances which can conduct electricity, they have free electrons. Okay. Okay, now let us see, we have done the movement of the charges, which we call as the current. We have done the amount of charges, Q is equal to NE. Now, we have also discussed about the electric potential. So what do you mean by electric potential? I'm just discussing electric potential difference. So what is electric potential difference?
So, amount of work done in a moving object.
Not moving object, in moving a positive charge. Okay. Amount of work done in moving a unit positive charge from one point to another in an electric field is called as the potential difference between these 2 points. The potential difference between these 2 points, I'll be calling it BAB. Potential difference between A and B will be equal to potential at B minus potential at A, and it will be equal to the amount of work done from A to B per unit charge. The SI unit of electric potential. Yes, what is the SI unit of electric potential?
Sir, volt.
SI unit of electric potential is volts. And we have written the simple formula for this, that V will be equal to W over Q. Okay. Now, can anyone define 1 volt? I have done already. I want you to define 1 volt. So try out defining 1 volt. When will you get your potential as 1 volt?
Like when the work done is 1 joule to move 1 coulomb of energy. I mean, sorry,
1 coulomb of charges.
charges.
Yes. So if 1 joule of work is done in moving a charge of 1 coulomb from one point to another in an electric field. If 1 joule of work is done in moving a charge of 1 coulomb from one point to another in an electric field, the potential difference between the points is said to be 1 volt. So we call the potential difference between the 2 points to be 1 volt. If the work done in moving the charge from one point to charge of 1 coulomb from one point to another is 1 joule. Okay. So, okay, which is the instrument used for measuring the potential?
Voltmeter.
Voltmeter.
Voltmeter. Okay. Anything about voltmeter? What about the resistance of voltmeter?
It has ideal voltmeter has infinite resistance.
Very good. So it has infinite resistance. How do we connect the voltmeter?
Parallel to the
Parallel.
Yes, voltmeter is always connected parallel to the circuit. Very good. So this was all about the electric potential. The instrument that we use is the voltmeter. it has infinite resistance, and it is always connected in parallel to the circuit. Very good. Now about the current. Yeah, what is the source of electric potential? Can anyone tell me the source of electric potential?
Battery.
Battery. Very good. So we use as the source of electric potential I consider as a battery or a cell. So a battery or a cell is a source of electric potential. Now the current, electric current. See, now I had discussed everything in detail. Now in short, we are recalling everything and we are getting everything in context. That means what should be written in the exams, right? So what is electric current? Can anyone define electric current? Yes, can anyone define electric current? Yes, see, the rate of flow of charges with respect to time is called current. Now, the symbol of current is I. We'll be using throughout this chapter the symbol I for current. So you write I equals to Q by T. How fast the charges are moving, that we call as current. So we write I equals to Q by T, and SI unit of current is ampere. SI unit of current, that is ampere, denoted by capital A. Okay, from this, let me give you one question and let's see if you can answer through it. Okay, so here you have find the amount of charges that flow when a current of find the amount of charges that flow when a current of 50 milliampere flows Okay, so try to answer this question. You have to find the amount of charges that flow through a point in 5 minutes when a current of 50 milliampere flow through it. Yes, anyone got the answer? I'm just waiting for your answers. Is there anyone who got the answer? Yes, is there anyone?
Sir, 1 minute.
Ayonija, I want to see everyone's answer. If you do not answer, your answer can be incorrect. But if you don't answer, that means you are not there in the class. You are not attentive. Okay. Anyone got answer? I should see the direct message as the answer. And if I'm not getting answer from anyone, that means you are not present there in class. Rijwana, what about your answer?
Still doing, sir.
Okay. Meher? Meher Charan?
Yes, sir.
Okay, which formula will we use here? Meher, which formula are we going to use?
Sir, I is equals to QT or something.
So not something, just tell me clearly which formula should we use now? I want to find the amount of charge that flow.
Sir, I is equals to QT.
I is equal to QT. Do we have any formula I equals to QT?
I mean,
See, the formula is here and still you can't read. The formula is I equals to Q over T. It's not I equals to QT.
Q by T.
Yeah. So we'll use this formula I equals to Q by T. Now out of this, what quantity is given to us?
Sir, current and time.
Current and time. So at the place of current, what should we write?
50 ampere.
50 ampere? No. The current is 50 milliampere. It's not ampere. See, when you are writing like this MA, it means milliampere. So this is 50 milliampere. And to convert milli into ampere, see what we were doing when we were kids of class 8, we used to divide it by 1000. Isn't it? When I wanted to convert millimeter to meter, how do I convert it? Divide by 1000?
Yes, sir.
Yes. So 1 over 1000. But now we will not be doing such things. I know that 1 over 1000 can be written as 10 to the power minus 3. Can I write it like this?
Yes, sir.
Okay. So from now onwards, keep an idea of this. I'm giving you all a shortcuts. Whenever you are written milli, milli means 10 to the power minus 3. Milli means 10 to the power minus 3. And when you have micro, micro means 10 to the power minus 6. Got it? So if at any place you read micro, micro means 10 to the power minus 6. Milli, then it should be 10 to the power minus 3. So here we have 50 milliampere. So I should be writing it 50 multiplied 10 to the power minus 3 as the current. This is the current. Time is given to us as 5 minutes. So for the SI unit, I must convert it to second. 5 minutes should be equal to 5
300.
multiplied 60. Yeah, that's 300 seconds. Now I want to find out charge. So use the formula. Charge Q will be equal to I multiplied T, and hence I is given to us as 50 multiplied 10 to the power minus 3 multiplied 300. So there are 3
15.
zeros over here, 3 zeros. So 10 to the power 3 multiplied 10 to the power minus 3, that vanishes. You have 3 times 5, that is 15 coulomb of charges. Okay. So how many of you did get the answer as 15 coulomb? Yeah, Pranaya
Sir,
got
I got it
15.
wrong. Before.
Pranaya got, got 15 Coulomb. And Dhaira got it wrong. Dhriti got it wrong. Kashvi. Okay, I think, okay, Kashvi, you got 15,000 into 10 to the power minus 3. Okay, the answer is correct. Okay, but if you multiply 10 to the power minus 3, you get the same 15. Also, the answer is not in ampere since we are finding the charge, so it should be in Coulomb. Okay,
Yes, sir.
so
Later,
Akash, yes, Kashvi.
later I sent you in Kulam, sir.
Okay, so yeah, I don't see later any messages. Okay, yeah, you written coulombs. Okay. And Dhriti gave 6 into 10 to the power minus 3. So Dhriti, you are wrong. Okay, now let's do one more question here. So now the question is like this. Find the current flowing through a wire find the current flowing through a wire if 60 microcoulomb 60 microcoulomb of charges flow per flow each second. Okay. So just a very simple answer. I think it shouldn't take more than a minute. I'm waiting for your answers.
So once previous show the previous page, sir.
Okay. Here is the previous page.
Completed, sir.
Okay.
Sir, how many coulombs is 1 microcoulomb?
Just I told you the meaning of milli and micro. Okay.
Oh, yes, sir.
Remember like this, when you have milli, so milli means 10 to the power minus 3. Micro means, micro is written like this also, micro, which is 10 to the power minus 6. Okay. You can also remember pico. So pico will be 10 to the power minus 12. Okay, I think I'm getting the answers. See, the answer will be it's very simple. I get I equals to Q by T. So the amount of charges which are flowing, amount of charge which is flowing is 60 microcoulomb. So I can write it 60 multiplied 10 to the power minus 6 divided by time. So each second means 1 second. So that is your current, 60 times 10 to the power minus 6 ampere current, or you can write it as 60 microampere of current. If someone has got this answer as 6 multiplied 10 to the power minus 5 ampere, this is also correct.
Yes, sir, I got this.
So this is also correct. Okay, Huria, 6 point. Okay, the class is supposed to end at 6:50. Okay, the class is from 6:10 to 6:50. That is a 40-minute class you have.
6:50, no, sir.
Yeah, 6:50.
Okay, sir.
So the class will be every day. Class is for 40 minutes. Anyone having any other doubts?
No, sir.
Okay. Okay, so let's try to do a question which is again a similar, you can say. Find the current going through a wire if 2 multiply 10 to the power if it is 2 multiply 10 to the power 18 okay 15 electrons cross a given surface in a minute. Okay, so try to find out this. This question is also based on the definition of current. Again, the same formula, but there is a combination of another formula also. You will require to use another formula, which we have previously done. Okay, so I think you should consider this question for your homework. Okay, try to do everyone. Take this question as this, take this one as the screenshot. Solve this question, and if you are able to tell it, obtain it, tell the answer in the next class. Okay, be ready with your answers in the next class. Okay, this is 2 multiply 10 to the power 15. Again, I'm saying this is 2 multiply 10 to the power 15. This is exponential. Okay. Okay, so bye everyone.
Bye, sir. Bye, sir.
Bye, sir.
Bye, sir. Thank you, sir.
Okay, bye.